Oh yeah, when I was listening to the 2 clocks experiment, where they had 2 atomic clocks, they situated one on the ground, and then they put one on an aircraft and sent it all the way around the world, and then put the 2 clocks next to each other after this experiment had been done, and one had lost time to the other one, whereas if they'd been sitting together they'd have been exactly the same because they were atomic clocks. And this proved that motion affects time. You've got to imagine this, right, and I'm not joking. This is pretty drastic. Now, if you stand up a lot in your life, your head will be going slightly faster than your feet, ever so slightly, because the world's spinning and you're standing on it. So if you live 100 years and you stand up for 50 years of that, half your life, your head will have travelled through time in comparison to your feet, or vice versa, you see what I'm saying? Which could put you out of sync, couldn't it? So it's probably best to do a lot of handstands just to balance things up. Now, to make things even more terrible than that, than your body going out of sync with itself, would be, let's say you live in the same city and the city's situated around a mountain, and some of the cities are around about 1,000 feet and it snows a lot, and other parts of the city are around about 20 feet above sea level. So there's a good 900 feet difference, but you live in the same city, and there's 2 people. There's one person, he lives down near the river, and the other person, he lives up near the Peast. And the person that lives up near the Peast, he was born up near the Peast, in the hospital up near the Peast, and he gets a job on the Peast, and he spends most of his life at the Peast. Whereas the bloke who lives down near the river, vice versa, he spends most of his time near, well, basically near sea level. Now surely, if these 2 met, there'd be a time dilation between the 2 down. They were born on the same day, let's say, at the same time. Is the person who lived up the mountain older because he's been travelling faster? Ever so slightly. And therefore, when they meet, are they actually meeting, or are they not meeting? Is it some kind of paradoxical conundrum or something? Anyway, so I devised this experiment to prove it wrong. So you get 3 watches, you go into a shop and you buy 3 watches, or you order 3 watches which are identical. Okay, and you drive to a point in your country, I say because I'm in England, Land's End, and you take one watch, you set all the watches to exactly the same day, exactly the same hour, exactly the same minute, and exactly the same seconds. You take one to a stone in Portland Bill or somewhere like that, yeah. And you take one to the side of your tyre, or glue one to the side of your tyre, and you put one on your wrist. And you drive from Land's End to John O'Groats. Now at this point, the one that's been glued to the rock at Land's End has pretty much stayed where it is in relation to the planet, relatively speaking. Whereas the one on your wrist has been travelling at an average speed of, let's say, 40-45 miles an hour. Sometimes faster, sometimes slower, but an average of about 45 miles an hour, I should imagine. And the one on the tyre has been travelling probably around about, I don't know, 200 miles an hour, average. So obviously the one that's on the tyres travel a greater distance than the one that's on your wrist, although relatively speaking they travel the same distance. The one on the tyres quite clearly travelled a considerable distance more than the one on your wrist, and at a greater speed. So it should have travelled through time. It should now be slower than the ones on your wrist. Now drive all the way back again with the same conditions, yeah, and the one on the tyre should be slow, the one on your wrist should be a little bit faster, and the one that was glued to the rock should be exactly what time it was set at. So you know what I mean, it should be, if it was 2 o'clock when you left and it was 2 o'clock when you came back, it should be 2 o'clock, you know, as long as it was keeping time correctly. Then you do the same experiment, you know, but you do it 3 times. So each watch gets to do the journey in each position. Okay? Now at this point, at the end of the 3 journeys, all 3 watches should be back at the same time, and they should have gone out of time and come back to time. That's the best way of proving it, isn't it, really? You know? And even that, all that's going to do, right, is going to show you that gyroscopic forces from the speed of the tyre affects electrons. Alright? Just like taking off and landing, accelerating, and the gyroscopic forces created by jet engines affected the atomic clock in the atomic clock experiment. That's what I'm saying anyway. It's up to you, you make your decisions. That's the way it is.